This molecule is phthalic acid. When phthalic acid is treated with ammonia and the mixture is heated, phthalimide is obtained. So this is phthalimide. Phthalimide has a hydrogen and this hydrogen is very acidic. So this hydrogen is very acidic. And this can be shown by writing the corresponding conjugate base structure and its stability. So this is acting as acid, phthalimide, and this is corresponding conjugate base. So conjugate base of phthalimide is resonance stabilized. So we can write two resonating structure or we can flow electron cloud this side. So basically phthalimide has three resonating structure and negative charge is just spread over nitrogen, oxygen and another oxygen. So these are resonating structures. So due to resonance, conjugate base of phthalimide is stabilized. When phthalimide is treated with a strong base, like KOH, so we will have acid-base reaction and corresponding salt is formed. So this is potassium salt of phthalimide. Now potassium salt of phthalimide can act as a nucleophile So it can act as a nucleophile. So let us say this reacts with alkyl halide. We have ethyl bromide. So we will have SN2 reaction. And product will be N-ethyl phthalimide. Now the N-ethyl phthalimide can be hydrolyzed, and this is generally done in basic medium. So we will have basic hydrolysis of phthalimide, basically N-ethyl phthalimide. So this is treated with OH minus in the presence of water, and this is nothing but hydrolysis. What happens? This bond breaks here and this bond breaks here, and the final product is so let us say we have NaOH. So we will have sodium salt plus ethyl amine. So this reaction is used for preparation of primary amine. So this is the primary amine. So this reaction is used for preparation of primary amine. Now mechanism of hydrolysis step is similar to mechanism of amide. You may remember hydrolysis of amide. So N-ethyl phthalimide is also a amide. You have CO and nitrogen. So this is also an amide. Only thing is this is a cyclic amide. Cyclic amides are called lactam. So let us write mechanism for hydrolysis. In the first step, OH minus will act as a nucleophile and it will attack on carbonylic carbon, and we will have tetrahedral intermediate. So this is the tetrahedral. Now in the next step, we can break the nitrogen carbon bond and we will have this product. Nitrogen will have a negative charge. So in the next step we will have acid base reaction. So this is intramolecular. Nitrogen will take a proton so we will have this product. Let us say medium has Na plus, so we will have sodium salt of acid. So this is half hydrolysis. What we have done, we have broken this bond and we have added a hydrogen to the nitrogen. So this is half hydrolysis. Same steps can be repeated. Basically here we will have C double bond O. So in the next step, OH minus will again act as nucleophile and it will attack on carbon. This opens. Now in the next step, we can return back the negative charge and we can form a double bond. So we can remove this one. So this will act as a leaving group. Now in the next step we will have acid base reaction. So we have this one, sodium salt of acid. So this will take a proton so we will have ethylamine and sodium salt of phthalic acid. So we have basically added 2 hydrogen to the nitrogen. So finally this nitrogen gets freed and in place of these bonds we have hydrogen. So in the whole reaction we have added 2 hydrogen. We have added 2 hydrogen to nitrogen atom. That's why this reaction is used for preparation of primary amine. Now let us say, if I say, how will you prepare methylamine? So this is a primary amine. So we can use Gabriel Phthalimide synthesis. So we can have this one and treat with KOH. So this is phthalimide. Now next step, we can treat this one with CH3CBr, and then we can do hydrolysis, basic medium hydrolysis, and this will generate CH3NH2. So Gabriel Phthalimide synthesis can be used for preparation of primary amine, and the mechanism is simple. First step is acid-base reaction, next step is nucleophilic electrophilic reaction, and finally we have hydrolysis. Hydrolysis step is similar to hydrolysis of amide. Only thing is, this time we have 2 times hydrolysis. So finally nitrogen gets freed and nitrogen has 2 hydrogen.